Hi, today we're talking about section 1.0, whole number operations notes. Recall the four basic operations. We have addition, subtraction, multiplication, and division. Let's look at this chart here. So here's our four operations. Here's some words that you might hear referring to these operations. When I ask you for the sum, it means to add the answer to an addition problem. The answer to a subtraction problem is the difference. The answer to a multiplication problem is the product. And the answer to a division problem is the quotient. Here's what the symbols can look like: addition, subtraction, multiplication can be shown with an X or a dot, and we're actually going to try to stay away from using an X from now on, now that we know we can use a dot, because an X is going to look like something that we're going to learn later in the school year called a variable. So this is our preference. And then division can be written three ways. You can use the division sign, fractions are just division, and long division setup. Okay, so example 1, adding and subtracting whole numbers. The bar graph shows the attendance at a 3-day art festival. What is the total attendance for the art festival? So first we need to understand this chart. So this chart gives me a couple different titles. We've got a label for the X, we call this the X-axis. It's the number of days or what day it is. And then we've got on the Y-axis going up, we've got the amount of people. So this means that on day 1, there were 2,570 people. On day 2, there were 3,145 people. And on day 3, there were 3,876. So if I want to know what is the total attendance, it means that I want to combine those three numbers. I want to find the sum of those three numbers, which tells me to add. So I'm going to show my work. And I'm going to add these together. 0, 5, and 6 becomes 11. I carry the 1. 7, 4, and 7 become 18. Plus 1 is 19. 5, 1, and 8 is 14. Plus 1 is 15. Carry the 1. And 2, 3, and 3 is 8. Plus 1 is 9. So my answer is 9,591 people. We make sure we label all of our word problems. Okay, so we answer the question, what is the total attendance? 9,591 people. Part B, what is the increase in attendance? So we want to know what the change is between day 1 to day 2. When we find change of something, it means we're finding the difference between them. And we know difference is the answer to a subtraction problem. So we're going to take day 2's attendance, 3,145, and subtract day 1's attendance. Okay, 5 minus 0 is 5. We cannot do 4 minus 7, so we are going to cross out the 4, make it a 14, borrow from the 1, and make that a 0. 14 minus 7 is 7. We cannot do 0 minus 5, so we have to borrow again. We're going to make that 0 into a 10, borrow from the 3, and make it a 2. 10 minus 5 is 5. 0 minus 0 is 0. So when we answer, what is the increase in attendance? 575, and we label it, because it's a word problem, people. Okay, example 2, multiplying whole numbers. A school lunch contains 12 chicken nuggets. 95 students buy the lunch. What is the total number of chicken nuggets served? So we need to decide what operation we are going to be using for this. So a school lunch, one lunch contains 12 chicken nuggets, but there are 95 students buying that exact lunch. So this tells us to find the product or multiply to get our answer. What is the total? We're looking for a total. Okay, so I'm going to take 12 chicken nuggets times 95 students. 5 times 2 is 10. 5 times 1 plus 1 is 60. Before I move on to multiplying the 9, I need to add a placeholder because this is saying I am actually multiplying by 90. So I need that placeholder. 9 times 2 is 18. Bring the 1 up. 9 times 1 plus 1 is 10. And when we add these together, we get 1,140. Now remember, you can use estimation to check the reasonableness of your answer. We want to make sure this actually makes sense. So I'm going to say, let's do a check. Let's do 12 times 95 is really close to 100 students. Well, 12 times 100 is 1,200. Those are decently close to each other, so I think my answer is reasonable. So my answer is, answer the question, word problem, what is the total number of chicken nuggets served? 1,140 chicken nuggets. Okay, example 3. Dividing whole numbers, no remainder. You make 24 equal payments. When we say equal, we know it's either going to be a multiplication or a division problem. We make 24 equal payments for a go-kart. You pay a total of $840. How much is each payment? So this is going to be a dividing problem. We're going to find the quotient. And the reason we know that is we are given a total amount. We are told that we have equal payments, and we want to know how much each part is. We're separating this into parts, each payment. So we're going to do 840 split into 24 equal groups. 24 does not go into 8, so I put an X right above 8. 24 goes into 84 3 times. 3 times 24 is 72, and we subtract. We have to keep going because we have a remainder here, so I'm going to bring my 0 down. 24 goes into 120 5 times. 5 times 24 is 120, and we are left with no remainder. So my answer is, how much is each payment? $35. Okay, final example, real life application. A 301-foot high swing at an amusement park can take 64 people on each ride. A total, that word each showed up, a total, and we have total again, of 8,983 people ride the swing today. All the rides are full except for the last ride. How many rides are given? How many people are on the last ride? So let's focus on that first question. How many rides are given? Well, we have a total of 8,983. And we know that each ride can take 64 people. So we're going to split this into 64 pieces. We're going to see how many times 64 people can ride this. So we're going to set up our long division here. $64 does not go into 8. It goes into 89 one time. We have to bring down our 8 so that we can continue working. 64 goes into 258 4 times. 4 times 64 is 256. We subtract and we get a remainder of 2. We still have a number to bring down. 64 goes into 23 0 times. And that leaves me with a remainder of 23. So my answer is, how many rides are given? Well, I know that 64 goes in a total of 140 complete times, but because we have this remainder, it means that we have people that still have to go on the ride. So there needs to be one more additional ride on top of this 140 complete rides. So 140 rides plus the additional ride for the extra people is going to give me 141 rides. So that's for my first question. My second question, how many people are on the last ride? Well, we have a remainder out of the 64 people that we were dividing by, which tells me that 23 people were on the last ride, because that was my remainder. And that is the end of our 1.0 whole number operations notes.